Now we're going to take a look at question 2, and we've got this diagram, and it shows it's an object held horizontally by a string. One end of the object rests on a support and the other end is held by the string. The object is in equilibrium and point G is the centre of gravity of the object. The mass of the object is 1.2 kilograms. The tension T in the string is 5.1 newtons. Might just write that in. So that's 5.1 newtons. And the string makes an angle of 40 degrees with the vertical. Okay, the first part then it says take moments about the support and calculate the distance d. So d is the distance from the support to the weight of the object, and it tells us that the string is 0.75 meters long. Okay, and we're looking for 3 marks and it wants the answer in meters. So let's do that then. Because we know that the object is in equilibrium, what we could say is that the sum of the anti-clockwise moments must equal the sum of the clockwise moments. And if we have a look, we've got to take them about d. So if I look here, there's d. If the weight of the object, that would try to make it rotate in a clockwise direction, and we could see that t would try and rotate it in an anti-clockwise direction. Let's make my pen a bit thinner. And what we need to realise here is we need this distance. Well, this distance here is 0.75, but in order to take a moment has to be the perpendicular distance to the line of action of the force. So this, because t here is not perpendicular, we need to know what component of t is perpendicular to this 0.75 meters. So I would say that then is going to equal t cos 40 multiplied by my 0.75, and that's going to equal the weight of the object, which it tells us is, well, it gives us the mass, which is 1.2 kilograms, so I need to multiply that by 9.81, and that is all going to be multiplied by d, and it tells us that t is 5.1 newtons, so let's substitute that in. So that gives me 5.1 multiplied by cos 40 multiplied by 0.75, and if I divide through this by this, that will give me my d. So divided by the 1.2 times 9.81, that equals d, and that comes out as being 0.25 meters. And now finally on to part B, just a single mark. We've got to explain why the force at the support cannot be vertically upwards. So here's the support. Why can it not be vertically upwards? Well, it does tell us early in the question the whole thing is in equilibrium, which means not only must the sum of the moments equal 0, but the sum of the forces must almost equal 0. So, and if we have a look here, well, the weight, yes, well, the weight is vertically downwards, but t is not vertically upwards, so we could think of t as being made up of 2 components. So t is going off in this direction, and I can think of that as being made up of both a vertical component and a horizontal component. So therefore the support D must also have a horizontal component equal to the horizontal component of T. So I would put my answer down as being something along the lines of just change my colour. The force at D has to have a component that is horizontal to cancel the horizontal component of force T. There we go.